Hello, I'm Alistair Stevenson, reporting for The Inquirer, and today I'm talking to Ken Levine about Bioshock Infinite and his experience working on it. Now, Bioshock Infinite is a big departure from previous games. Can you tell us a little bit about the new environment and the challenges you faced creating it?
You know, from a technology standpoint, it was very, very different. It was a new engine because the first Bioshock game was essentially was a dungeon, and from a technical standpoint, it was underground effectively. Even though it seemed like there was water outside, that was mostly just art that made that happen, and it was sort of narrow corridors and fairly limited spaces, and just a couple of AIs at a time, and everything was very dark. Sight lines were very short, and that made our lives a lot easier. With Infinite, we wanted to make a much bigger, more expansive city, and the lighting it was much more about light and big, hot, sunlight and things like that. So we had to go from sort of a modified version of the Unreal Engine 2.5, which we had put some Unreal Engine 3 stuff into, to a full version of Unreal 3. And then our tech team, led by Steve Anachini and Steve Elmore, wrote a deferred lighting renderer, which allowed all things to be lit consistently in the world. So things in sunlight, like characters are lit consistently with the world, and objects are lit consistently with the world, and that was a big piece of technology they took on. The floating city was a real challenge because the Unreal Engine does not really want to have giant moving pieces of geometry. So that we did the programming team did a very clever bit of work, and I won't reveal all their secrets here, but they'll probably talk about it after the game comes out, of how they made these giant floating sections of the city move, and how they made all the vehicles, these barges and things that move around that you can jump on, jump off. That was a very challenging thing to do, and of course you're always working with performance and memory and stuff like that. The other big challenges were the skylines, getting those right, getting those to feel right, getting getting enemies to get on them and get off them, and sort of the pathfinding issues involved with that were, I think, a real challenge for the team, but they did an exceptionally good job. I mean, even Elizabeth can get on them and get off them, and when we have enemies like the handyman who can sort of jump around and from one space to another, so the pathfinding challenges are so much greater than you'd have in something with just a flat ground like Bioshock 1. I think one of the biggest tech challenges was Elizabeth, who's this companion AI we have, which I actually gave a talk about her at the BAFTAs last night, and she is really a combination of a lot of sort of heuristic systems, a lot of AI, and a lot of content. And because unlike most companion AI, she's not just a turret that walks around and shoots things. She is, which is effectively what a lot of sort of companions are, like in a lot of sort of military games and things like that. She is somebody that has to be engaged in the space when combat's going, when it's not going. And so like for instance, one of the hardest things to do for an AI is when you're fighting an AI, you can sort of take a lot of shortcuts because they're shooting at you and explosions are going off and they're at a distance usually. But with somebody who you're just standing next to, like, what do people, first the question, there's a sort of an art question and a design question. What does somebody do when they're just sort of hanging out in space? How do they look at things? What is too close to, what's getting too close to you? What's too far from you? How do people turn their head? Do they turn their eyes first? Do they turn their head first? How do people interact with things in the world? How close do they get to other people? All those questions we had to answer first, and the way we did that is the artist sort of went and looked at theirs. We said, go look at don't tell your spouse or your husband or your boyfriend, but go watch them creepily, and observe them and see what they do. So first you have to answer those sort of content questions. But then you have to figure out how to make those things happen. How do you make Elizabeth interested in things in the world? And the way they ended up doing that is they would tag objects with all these sort of markers, and the more they can indicate by putting more markers on something, they can indicate how interesting that was to her. And because it's not a game about cutscenes, and Elizabeth is generally behaving she performs scripts, but she's doing it based upon opportunities. So she can be in a space, and she may, if you just run through that space, she's not going to interact with things. But if you hang out, she may look at this, she may look at that. She may, if she just looked at a bunch of flowers first, she's not going to look at flowers. She's going to look at something else. So there's all these heuristics running underneath, and all this ability for her to sort of interact with objects in the world, moving and non-moving objects, which is very challenging, getting her to line up with those things properly. There was just a huge amount of work, and in combat, you know, A, the most important thing was you never have to protect her, but B, that she stays, you never want to be running around in combat having her bumping into you. So she's very smart about observing the player, taking cues from the player about what the player is doing, because we always want her to be a help to you, never a hindrance. And she also has to be a bit of a mind reader, like where's the player, if she knows where the player is going, it's easier for her to sort of keep up with him. And so there are some clever things that the programmers came up with, like about knowing what the player's quest was and making some educated guesses based upon where the player might be going upon that. But then there are moments like in combat where you like run out of ammo, and sometimes she'll say, "Booker," and you turn and she's got a reload for you with some ammo, and she, you know, tosses it to you. But we have to get her in the right place to do that. We have to make, you know, that toss work between her and you in a very seamless fashion. And that stuff is all, you know, really, it's easy in real life, but it's not so easy, you know, to make AIs do that. She's just got a huge range of capacity of action that you really haven't seen in other AIs, let alone just, you know, her, you know, just the challenge of writing an interesting character, making it an interesting looking model, getting a good performance out of the actor, getting good motion to the motion capture, just then all these sort of opportunistic, heuristic things going on with her just made her an incredible challenge, but also incredibly rewarding when she finally really started working.
Great. And you talked there sort of about the human elements and things you can do outside of the technology a lot of times as well in there. To what extent, because obviously the Xbox and PlayStation are sort of coming towards the end of their life cycles, to what extent was the hardware a real issue for you guys there, sort of going within these confines?
Well, you know, you always every hardware has its advantages and its limitations, and obviously the Xbox and the PS3 are, you know, they're not new pieces of hardware. So you have, and you're also making a game that you want to make great running on modern PCs, and so you always have to figure out how to sort of get a consistent experience without compromising on the higher end platforms like the PC. So, you know, you have to really, you have to think about those things from the outset. If you don't, you have to design for those things from the outset. If you don't, you're really going to run into trouble down the road. And look, like all games, there's, you know, it's the same like the Xbox and PS3 versions are the same hardware that was running on Bioshock 1. So, but the technology is way more advanced, and it really is not because we got more memory out of those machines, because they didn't have any more. It's just programmers learning new techniques, and, you know, learning from their work before and learning from each other, and, you know, going to trade shows and reading journals, and, you know, and learning new ideas, like, you know, for lighting renderer and floating worlds. All those are just sort of some of them were sort of known techniques like deferred lighting, but to do that and make it perform properly and make it, you know, make all the right decisions. So, and that's what it is. It's constant trade-offs. You know, how much of the cycles are you giving to AI versus how much are you giving to, you know, rendering and physics and all that. And you just have to make choices along the way. And the best games make the best choices. You know, that's really what it comes down to, and leverage the resources most effectively. I mean, Elizabeth is a big resource drain, and I don't mean that in a negative way. It means we chose that. We wanted her to be important, and we knew that was going to have a cost. When, you know, in Bioshock 1, you didn't have an Elizabeth, so just from there, you were already sort of a little bit behind the eight ball in terms of what you could do. But then we wanted these huge spaces, as well as much smaller spaces, and larger number of AIs, and all this stuff going on, and moving worlds and all that stuff. So that basically the programmers just had to bring the programmers and the artists and the optimizers had to bring all their crafts together and make it happen. But it was not, you know, it wasn't easy.
So in that extent, are you looking forward to the next generation? Any sort of good plans to PlayStation 4 and bringing things you learned into that?
Yeah, I mean, look, it's always, the basics are always good, right? It's always good to have more memory and, you know, more, you know, better processors, more memory. That stuff's always good. I haven't thought deeply about what the next generation means in terms of our games, because I'm still sort of finished. You know, we just finished this one. I'm out promoting it, but I need to go step back, and the team needs to step back, take a breath, and say, okay, well, what's next, and what does new hardware mean for us? And but I think that, you know, the stuff we make is not strange. We're not a technology-driven company, though we have extraordinary technology in this game. We have ideas for things we want to see in the game, and we have a great engineering team that just makes that happen. And sometimes, you know, you say to them, like, oh, I like floating world, and as a designer I don't really know what that means, but they probably, you know, took a very deep sigh, you know, and then, you know, set about going about to make that happen. And, you know, and that's what that's the great thing about a technology team that is really focused on making a great game rather than showing off a particular piece of, you know, hot tech, because you're going to get the best results out of something that is both technologically exciting and, you know, works in the game.
Brilliant. Well, the game looks great, and we'll be sure to send you our review once it's done. I'm Alistair Stevenson. Thanks for watching.